Hello guys, I'm Kaustubh and today I'll be talking about introduction to data mining and data warehousing. So moving ahead, what is data mining? So data mining is the process of extracting useful information from large sets of data. It involves using various techniques from statistics, machine learning, and database systems to identify patterns, relationship, and trends in data. This information can then be used to make data-driven decisions, solve business problems, and uncover hidden insights. So now, data mining. In general terms, speaking, what is mining? Mining is nothing but the process of extraction of some valuable material from Earth. For example, I can say coal mining and diamond mining, right? So, in context of computer science, data mining can be referred as knowledge mining from data. Now, this is very important here, knowing the difference between information and data. So, you can say data mining is nothing but getting information from data, right? It's basically the process carried out for the extraction of useful information from a bulk of data or data warehouse. So some people might find the term a little confusing. In case of coal mining or data mining, I mean diamond mining, so we carry out the mining process and the output will be coal or diamond. Whereas in data mining, the output or the result of data mining will not be data. Instead will be useful information. So there is a difference between information and data. So moving ahead, data mining is a whole process. The whole process of data mining consists of three main phases that is carried out. So the first phase is data pre-processing. Data cleaning, integration, selection, and transformation takes place, and all of these come under data pre-processing. So then data extraction takes place, where the occurrence or the process of data mining takes place. And then data evaluation and presentation. Here, the analyzing and presenting of data takes place, or the results. Now, when I said information is extracted from data, so this information can then be used for analysis, right? It can be used to find patterns, and knowledge can be gained from this information. So these can be used in many fields. So some of them are financial analysis, biological analysis, scientific analysis, intrusion detection, fraud detection, and research analysis. Now, coming to data warehousing. What is data warehousing? First, most of us are familiar with database management system. So a DBMS stores data in the form of tables using ER models, and the whole point of a DBMS is to follow ACID properties. Now, taking an example, a DBMS of a college has tables for students, faculties, etc. that stores current information, whereas a data warehouse is separate from DBMS. It stores a huge amount of data, which is typically collected from multiple heterogeneous sources. So when we say heterogeneous, the sources from which data collected does not remain the same. It may be like file systems, databases, and any other sources. The goal is to produce statistical results that may help in detection making. So now, a common belief is that a database is based off of operational or transactional processing. So in a database management system, each operation is an individual transaction, whereas in a data warehouse, it is based off of an analytical process. Generally, a database stores up-to-date data, so it is based off of daily operations, is what you could say. Whereas a data warehouse stores historical data. It might be, for example, a college that has a data warehouse might store data of students probably from 10 years ago. So to analyze trends and how student scores are changing and finding patterns between them, these data warehouses are used. So need for data warehousing. Why do we need data warehouses? As I said before, an ordinary database can store megabytes to gigabytes of data, and that too for a specific purpose. For storing data of terabytes of sizes or huge amounts of sizes, the storage is shifted towards data warehousing. Besides this, a transactional database or a normal database doesn't offer itself to analytics. So analyzing data from these databases might often be tough or difficult. So to effectively perform analytics, An organization keeps a central data warehouse, so where all the data is stored here. So it might be historical data to be specific. So this historical data is analyzed, and then strategic decisions are made, and analyzing trends is carried out. So benefits of data warehousing. What are the benefits? Why do we need data warehousing? So better business analytics. Data warehouse plays an important role in every business to store and analyze all of the past data and records of the company. So as I said before, it contains historical information. So this information can be extracted, analyzed, and better decisions can be taken in favor of your company or your business. Faster queries. Data warehouse is designed to handle large queries. That's why it runs queries faster than a normal database. Improved data quality. Yes. So now in a data warehouse, the data gathered from different sources is being stored and analyzed. So as I said, it's heterogeneous. It can be file systems, databases, and other sources from where data can be collected, even sensors and stuff. So now when the information is stored, it does not interfere with other present data and add data by itself. So the quality of data is maintained and preserved. So if you get any issue regarding data quality, the data in a data warehouse will be solved. I mean, the problem will be solved by data warehouse team that an organization might have. So historical insights, the next one. The warehouse stores all your historical data, as I said before, which contains detail about the business so that one can analyze it at any time and extract insights from it. Moving ahead, multidimensional data model. So multidimensional data model is a method which is used for ordering data in the database along with good arrangement and assembling of the contents in the database. So now the data can be arranged in a theoretically 3D way. So now in a multidimensional way, basically not just 3D. It represents data in the form of data cubes. Data cubes allow to model and view data from many dimensional perspectives. So as you can see in the picture here, you can have many perspectives through which you can see data stored. It is also defined by dimensions and facts and is presented by a fact table. Facts are numerical measures and fact tables contain measures of the relational dimensional tables or name of the facts. Now, what uses a multidimensional data model? So OLAP and data warehousing use multidimensional data model. It is used to show multiple dimensions of data to users. Now, moving ahead, you might doubt what OLAP and OLTP are. So as I used OLAP before, we'll just look into the definition, and then we'll sort out the differences. So OLAP stands for Online Analytical Processing. So online analytical processing consists of a type of software tool. So it's a tool that is used for data analysis for business decisions. Now, what uses OLAP? For example, Spotify. So it analyzes songs based off of your preferences and might create a playlist. And similarly, Netflix. So it looks at your likings and creates movie recommendations. Now, OLTP, moving to OLTP, OLTP stands for Online Transaction Processing. Online Transaction Processing provides a transaction-oriented application in a three-tier architecture. So, basically speaking, both are tools. OLTP administers the day-to-day transaction of an organization. For example, ATM Center is an OLTP application. So, moving ahead, we'll sort out the difference. So, there are many differences here. We'll just go through each of them real quickly. So, by the definition of each, OLAP is well-known online database query management system, whereas OLTP is an online database modifying system. So data sources. So OLAP consists of historical data from various databases, whereas OLTP consists of only operational current data. Methods used. It makes use of data warehousing, whereas the OLTP makes use of standard database management system, DBMS. The application of OLAP is subject oriented, uses data mining, analytics, decision making, etc. Whereas OLTP is application oriented, used for business tasks. It's normalized. In an OLAP database, tables are not normalized. Whereas in OLTP database, tables are normalized. 3NF. I hope you know what normalization is. Usage of data. how the data is used. Whereas in OLAP, it is used in planning, problem solving, and decision making. As I said before, used to create patterns and find trends and all of that. Whereas in OLTP, data is used to perform day-to-day fundamental operations. The task now, it is used to create multidimensional view of different business tasks. So it reveals a snapshot of business's present tasks. So as I said before, stores historical data, stores day-to-day current up-to-date data. So purpose. It serves the purpose to extract information for analysis and decision making. So as I said before, patterns again, that's the purpose. So whereas OLTP, it serves the purpose to insert, update, and delete information from the database. So the basic operations, volume of data. OLAP has a large amount of data that is stored in TB and PBs basically. The size of data is relatively small. In historical data is archived, for example, MBs and GBs. This is your basic database. This is your data warehouse. So queries. Queries are relatively slow as the amount of data involved is very large, and queries may take hours to execute. So in an OLTP, queries execute very fast because smaller data, quicker operations. So update. The OLAP database is not often updated. As a result, data integrity is unaffected. Whereas in OLTP, the data integrity constraint must be maintained in an OLTP database. Backup and recovery. It only needs backup from time to time as compared to OLTP. Backup and recovery process is maintained rigorously. It's very important and one of the features that is to be constantly checked. Whereas the processing time in OLAP is complex queries may take lengthy time. As known, handles large amount of data, so may take a lengthy time. Whereas in OLTP, it is comparatively fast in processing because simple and straightforward queries. Types of users. Now we'll look at users that use OLAP and OLTP. So OLAP is generally managed by CEO, MD, and GM, whereas in OLTP, data is managed by clerks and managers. Operations on OLAP only read and rarely write operations because it's updated not every day and is updated just regularly. Regularly in the sense might be, but not as regularly as the one in OLTP. Both read and write operations. So yeah, updates with with lengthy scheduled batch operations, data is refreshed on a regular basis. So as I said before, the user initiates data updates which are brief and quick. So as I said before in this point. So yeah, nature of audience. Process that is focused on customer, process that is focused on the market, OLTP and OLAP. Database design with focus on the subject, database design that is focused on the application, and productivity last. Improves the efficiency of business analysis, enhance the user's productivity. So analytics and user's productivity. That is the difference. Thanks for watching.